All right. Good afternoon. Good afternoon. Good afternoon, everyone. Sorry for another late session. Marami tayong ginagawa. Please bear with me. Alam niyo naman yung situation namin dito ngayon sa probinsya. Medyo nadalawaan kasi kami. So marami kaming mga ginagawa. All right. Sorry for another late okay, anyway, we can continue our discussions now regarding our navigation system. And previously, we talk a lot of navigations. Napakaraming topics kasi sa navigations. Yesterday, inabot natin up to yung yung weather radar, and our next topic now is your radio altimeter. All right. So, naririnig nyo ba ako, mga sirs? Can you acknowledge?
Yes, sir.
Okay, thank you, sir. Now, we have this radio altimeter. But talking about this radio altimeter, gentlemen, is different from the atmospheric barometric pressure natin. If we talk about the atmospheric pressure, we are talking about an input coming from the P2 static system through your ADC, diba? Yung air data computers ninyo. But this RA is not something like barometric pressure, but this one is an electrical signal sent by a computer through their antenna, of course, going to the ground, and it reflected back. So the time of transmission and reception, that will be converted into a what do you call this one? Distance. All right. It will be converted, so it measures the elapsed time between the signal of transmission and reception signal, and most likely it computes the distance from the aircraft to the ground. The thing here, gentlemen, is the main characteristic of your radio altimeter is it locks into the leading edge of the reflected waves, which enables to measure the distance between the aircraft and to the nearest obstacle. All right, so this one, gentlemen, the only thing here is the effectivity of your radio altimeter is only 2,500. All right. Beyond 2,500 feet, no more RA. All right. But if you have this one below, over a non-surface flat ground, you have the indications for your RA, or the radio altimeter. So it's an electrical systems that will measures the elapsed time between the transmission and the receptions of your system. All right, so this is how the system works. Of course, we have radio altimeter. All right, that radio altimeter now sends. You see, it's not a barometric pressure. So you have the RA1 and RA2. Most likely, RA1 is enough. RA2 is an option. And as you can see, the RA, gentlemen, is most likely interfaced directly to your symbol generator, and it will be directly presented in your EADI. Dito sa baba na to, makikita nyo yung RA. Diba, nandyan yung indications nyo ng RA. So yeah, the RA also has an interrelationship to your AFCS computer. So especially during autopilot. All right, but we focus on the yung indications natin doon sa EADI. So it gives a accurate height information when flying below 2,500. So meaning above 2,500, no more RA. That's why the radio altimeter is only most likely effective during approach and landing. And also during takeoff. Makikita nyo yung informations nyo RA. Pero once above 2,500 feet, wala na kayong RA. So applicable during approach space. And the RA information and the decision height is displayed in the EADI. So normally you can select the EADI through your EPIS control panel. So kita ninyo nung nakaraan, you can select the DH doon sa inyong ECP. Okay, so this is the systems now. So meron kayong isang reception, isang transmission antenna which can be found on the belly ng inyong aircraft. So what to do now is you need to energize your radio altimeter in order to transmit the signal. And as it reaches to a non-flat ground surface, then it will bounce back and receive by the reception antenna, and of course it will be processed within your transceiver. So meaning to say, it will compute the elapsed time of transmission and reception. And that signal now, after the processing of your radio altimeter, it sends now to your symbol generator. All right, you have two symbol generator, and the symbol generator number 1, of course, you have now the RA. All right, and also in the FO side, symbol generator number 2. Ganyan lang naman kasimple yung ano na. But you see, the RA is also interface to your ground proximity warning system. If something like there is a continuous alam niyo na yung EGPWS natin is most likely looking after the correct configuration of the aircraft. So in 5 modes, meron kayong 5 modes. But if you look on it, example for the enhanced ground proximity warning, it even increased to additional of 2 modes. That's why we call that as EGPWS. But alam nyo ba mga kapatid na yung EGPWS, which is looking after the terrain function, ang tawag na ngayon sa kanya ay TAWS. Alright, TAWS. Terrain Awareness System. Yan, Terrain Awareness System. At inherent na to ngayon doon sa inyong TCAS. I think napag-usapan na natin yung TCAS nung nakaraan. Diba? Kaya nga, ang ginagamit ngayon is T2CAS. Ano ibig sabihin nun? It's a combination of the TCAS and the TAWS version of your EGPWS. Kaya nga T2CAS. Bakit naging T2? Dalawang T. Terrain at saka traffic. Alright. So just a sideway. Nakalimutan ko atang banggitin yan kahapon during the explanation doon sa inyong TCAS. And yeah, anything it can cause the alarming also of your centralized crew alerting system. And also there is an interface which is directly to your AFCS. Kita niya mga kapatid, kanina. Yan, AFCS computers. All right, and also recorded in the FDAU. Yan, anything. You see now this one? Meron pala dito eh, natakpan lang pala kanina. Ayan, meron kayong interface ng TCAS dyan. All right. Okay. Ayan, so ito yung mga indications natin. So in cases maybe, yan, the radio altimeter information is in the right corner of your EADI. Yan, meron kayong RA dyan. So range of the display is -20 to plus 2,500 feet. All right. So if above 2,500 feet, it will not be displayed. All right, so it's not only the decision height, gentlemen, but of course interface also to your decision height. So it can be shown in the bottom left corner decision height. So this decision height can be yeah, we have the DH label. So you have the decision height. All right, decision height, and you can actually select through the knob. And the range of display of your RA, it can be 0 to up to 990 feet. All right, so decision height selection is made in the DH step. You see this one, DH test, and the inner knob of your EP's control panel. All right, so that is the indications, gentlemen, of your RA. All right, so yeah, different applications now. So aircraft height is equal to or lower than the decision height. So that's why you have this one, decision height. And when the aircraft height is equal to or lower than the selected decision height, you can see now the amber DH annunciators. All right, so see this one now. And you have now the yellow runway, something like that, until it reaches your yung tawag nito doon sa attitude heading na attitude natin doon sa pinaka center. Ang tawag na minsan natin dito is we call that as rising runway. Yeah, we call that rising runway. And then kapag meron naman tayong mga invalid readings coming from the RA, then you can see these amber dashes. All right, so warning, when the decision height is set to 0, decision height is not displayed in the EADI. Blanco lang siya. All right, so yan yung mga transition ng readings natin ng decision height. All right, so yeah, you can select. See this one, when the aircraft is on ground, the 100 feet RA test value. Right, if you press the test, you can see 100. Dito 100 RA doon sa inyong EADI. If you press the test post button doon sa inner knob ng inyong DH test, then you can see 100 RA feet. That is the test value of your radio altimeter. Yan. And you see ACS bus radio altimeter test inhibition. So test is inhibited gauge in the AFCS computer. So nakita nyo doon sa autoflight natin, meron kayong AFCS control panel. In the AFCS control panel, meron kayong lateral post buttons, lateral engagement. And one of them is ATP, what do you call this one? ATP approach. If you press that approach, it can cause the inhibition of your test sequence. So don't press the test sequence during tests. All right, so yeah, how, gentlemen, how to do it? This is a simulations of our system. So EP's DH test, you have this one, performs the decision height test, and then press the test push button, the inner knob. As you press the inner knob, then what to do? You can see now the runway symbol falls. You see this one? That is the runway symbol. And the RA information becomes 95 or 100 feet. All right. And simultaneously, in the first officer, warning also, all plugs are displayed. So may nakikita kayong mga XXX at saka yung attitude fail na yan. Yan. And dashes in the DH information, and the same RA is 100. And you can see the test information to the system indicating that ongoing test. But you see, don't press the APP in the AFCS control panel because it can inhibit the testing of your RA. All right, so once you release the DH test now push button, it causes the previous configuration to be displayed on both PFD. It goes back to normal. All right, so this radio altimeter test must be continued by pressing the DH test inner knob on the captain at the same test sequence takes place on the EADI, but symmetrically. All right. Okay. So what is this? Reception. So receiving now. So the radio altimeter transmitter sends a signal to the ground. All right. Sends a signal to the ground. Something like that. But then it reflected over a non-surface flat ground. And of course, it will send back. All right. The ground reflected signal is picked up by your reception antenna and then transmitted to your transceiver. And it will be processed and compute for the elapsed time of transmission and reception. And then, just like we mentioned earlier, it goes now to your symbol generator and present your decision height. All right. Yeah. Okay, and you have also the decision height. So you have the decision height, and then you can select it. And of course, you can monitor the changes and the selection of your decision height in the lower left corner of your EADI. All right. So you see, when the radio altimeter indicates an altitude lower than or equal to 500 feet, the landing gear is not extended, then it can create the sound generated landing gear not down. All right, so we have the 500 feet trip, and the aircraft now is now 500, and the pilots forgot to lower down the landing gear, then it triggers the landing gear not down sound. So altitude information is also transmitted to the EGPWS, to the autopilot, and to your TCAS, and to be recorded in the flight data acquisition unit. All right. So each symbol generator receives information from two different input of the transceiver, or the same RA transceiver output, or two separate. So it's two different output of your RA. So if we going back, gentlemen, you only have one transceiver, but you have a attitude output number 1 and output number 2. All right. Okay, and this is the locations now of your two antennas, transmission and reception antenna. All right, so yeah, we have the reception antenna and the transmission antenna, which are both located into the belly fairing of your aircraft. So your antenna is transceiver is a TRT AHBA transceiver, which consume is 35 watts, and they are interconnected to the transceiver by a 50 ohm types of PTFE insulation, Teflon. And your transceiver is located in the avionics rack, specifically on your 83 PU. All right. Okay. So simple presentation and application of your RA. All right, now we go to next topic. So we have, now we go now to your EGPWS, or to your GPWS. Okay. This is the one that we mentioned earlier, and one of the interface system to EGPWS is your RA. All right. See, it's the RA. We have the radio altimeter. So this proximity, ground proximity warning system generates visual warning caution, synthetic voice, yeah, and supplied by the other aircraft system. We have the air data, a radio altimeter, the flaps, and landing gear. So most likely this GPWS guys has a sorry, I think I mentioned 5 alerts. So it's a 6 alert modes establishing danger configuration. All right, so we have mode number 1, that is the sink rate. Mode number 2, excessive terrain closure rate. We have the descent after takeoff. We have inadvertent proximity to terrain with landing gear or flaps not in landing configuration. We have the descent below the modes that are activated when the aircraft is in the dangerous configuration. All right. All right. So these are the interfaces of your system. So we have the ground proximity warning system, but you see, we have an input coming from the radio altimeter, the symbol generator for your SG. We have the ADC, all right, your ADC computers for altitude, airspeed, and the vertical speed. We have the glide slope. This is your mode number 5. And we have also your landing gear lever and the flaps configuration. And of course, we have the go around mode. We have the in the auto flight system that we discussed. In the power lever, you have the go around, the GA push button, and you see this one in the lateral mode. You have a BC. This is your AFCS control panel, and you have the BC. So if you select the BC, it selects the back course of your localizer. All right. So what else that can we see here? So of course, our EGPWS or GPWS is supplied coming from your 115 volts. Bus number 2, if there are something like faulty in the system, you have a annunciator lights, GPWS or GS for captain and your FO. All right. And you have the glide slope inhibition. And in cases maybe there are fault in the system, it can generate the master caution, a single chime. But there is always, you can always clear the system in your CAP. All right. Now, we have this one, GPWS switch. What is the purpose of this one? Normally, it is in the norm configuration, but you can inhibit the flaps. That is your module 4. What does it mean? So example, you have this landing gear, right? And the flaps configuration. If the aircraft now is most likely at 500 feet and the pilot forgot to place the flaps landing, it causes the, what's that sound? The flaps too low, something like that. Or it can also be landing gear not down. All right. But you have these flaps override. It will inhibit. If you place it to off position, then it will inhibit the modes, the number 4 modes. So it means to say you can still land, but there's no more something like synthetic voice generated by the system because it overrides the flaps. All right, now we have also these inhibition modes. If you have a stall warning, gentlemen, is priority over the EGPWS or GPS. So it means to say it will inhibit all modes warning created by the GPWS if the aircraft is in the stall configuration. All right, so that's why the GPWS, gentlemen, is interfaced with your RCAU to generate any synthetic voice generated in the EGPWS as provided by the 6 modes generated by the system. All right. Okay, yeah, that's it. We have your GPWS. So GPWS is inhibited in case of stall warning generated by the crew alerting system. All right, so these are the different modes generated by the system, gentlemen. So we have excessive sync rate. So what is this for? If the aircraft is flying and there is an obstacle and penetrate a certain flight envelope, it causes the alarming of your synthetic voice generated by the RCAU. See, that's why you have the RCAU here. So what does it mean? Meaning it creates a synthetic voice. What is that? Sync rate, something like that. If the aircraft penetrates the sync rate. But say for example, if the pilots corrected the flight and it no longer penetrate the flight envelope, then what happened? It silenced the aircraft. But as you can see, mga kapatid, paano kung tuloy-tuloy lang yung lipad ng eroplano, lumipad na siya, sync rate, dumating sa punto na umabot na siya doon sa flight envelope ng pull up, then you can hear the pull up. Ibig sabihin, malapit ka na sa bumangga, di ba? It means to say, ano yung sync rate na yan? Sync rate. Mataas yung pagbilis ng pagbaba mo. Excessive sync rate. Sync is bumababa. Ibig sabihin, mabilis yung pagbaba ng aeroplano. Excessive sync rate. Alright. So we have also, aside from the mode selector, so ayan, we have also the module 2A and module 2B. What is that? That is your excessive terrain closure rate. So malapit ka nang bumangga, parang ganon. So kaya nga habang lumilipad ka at pumunta ka na doon sa flight envelope na yan, it can cause alarming. Ano yung alarm na yan? Terrain. You can hear now the terrain. And of course, paano kung dire-diretso lang yung aircraft at pumunta na siya dito sa envelope na to, and then it will cause the pull up indications of your GPWS. All right, so yan yung sinasabi natin kanina. So na-penetrate na niya yung envelope na yan. So and when the aircraft penetrates the outer warning, it causes the terrain. Alright, terrain. Paano kung dire-diretso lang, di isasabihin na niya na pull up, terrain, pull up. Ayan. Whoop, pull up, pull up. Ganun na yung magiging niya. Ibig sabihin, close proximity na siya doon sa pinakamalapit na obstacle. Alright, so at least malayo pa lang, meron ka ng forward looking doon sa mangyayari sa iyo yung status ng aircraft mo. So by penetrating those envelopes, meaning it can cause the alarming of your GPWS. So for this example, malayo ka pa lang, may terrain ka na. Pero kapag pumasok ka, ayan na, whoop, pull up. Alright. And you need to maneuver the aircraft. Alright. you need to maneuver, and kapag nalampasan mo yan, and then di okay ka na, di ba? Ganito alam niyo yung nangyari doon sa Cebu Pacific na DC-9, ganon. Lumipad sila sa Bacolod and then lilipat sa isang bayan. Dumaan sila sa bundok. Akala nila yung bundok na yon is ulap kasi minsan yung ulap doon nagsisettle yung ulap, di ba, sa bundok, doon nagsisettle yung ulap. So nagtunog na yung module 2, terrain. Wala, ulap naman yan eh. Kayang-kaya natin yan. Pumasok sa pull up, gumagano na siya. Terrain, whoop, pull up. Late na. Noong hinatak nila, anong nangyari? Bumangga na sila sa bundok. Diba? I think nandito si Sir Alan eh. So ganyan yung nangyari doon sa Cebu Pacific na DC-9. Diba? The pilots didn't hit the warning as created by the centralized crew alerting system. All right. So kapag paano kung nalampasan mo at yung distance mo from the mountain at saka yung aircraft mo is 300 feet, then of course it will stop the oral alerts and visual messages. All right. Now we have also this one, excessive terrain closure rate, but this one is during landing configuration. And there are two instances, right? We have the flaps not extended and also the landing gear is up. So what is that? 500 feet, di ba? Nakita nyo kanina, 500 feet. At nung bababa ka na kayo at hindi nyo nakalimutan yung flaps configuration or the landing gear, hindi nyo binaba, di anong mangyari? Tutunugan kayo. Di ba? Tutunugan kayo ngayon. So, parang i-consider niya ngayon na yung airport is terrain. So, in order for you not to be considered as a terrain, yung runway natin, kailangan, gawin natin yung procedures of lowering the flaps and also lowering yung landing gear natin. All right. Okay, paano kung lumipad uli? So after that, then the oral and the warning ceases. I-stop din siya kapag may clearance na siya. Mas mataas na siya sa most likely 500 or maybe 700 feet. Kita niyo dito, 700 feet. Meron na siyang clearance between the runway, then it ceases the oral. But if you don't like kasi na marinig yung mga ganon, pwede man baka naman kasi maglalanding ka talaga. Then what to do? You lower the flaps and you lower the landing gear. All right, so we have the number 3 also. Descend after takeoff. Ano yan? Pag takeoff niyang ganon, bigla siyang bumaba. Parang ganon. So, pag take-off niya, supposed to be, i-clear niya yan. Pero kapag pumasok yung aircraft, doon sa envelope na yan, tutunog na siya. Don't sink. Don't sink. Don't sink. So, anong gagawin niya? I-recover niya ngayon yung flight. At lumabas siya tumas siya siguro within 7,000 or 700 feet para mawala yung sound. Alright. Ano pa? Ito naman, yung number 4 naman ninyo, proximity to terrain. Alright, so ito yung binabanggit natin kanina. Maaaring palanding na yung aircraft, di ba? Palanding yung aircraft or mataas or mababa lang talaga yung aircraft towards a particular obstacle. So example, if the aircraft pababa maglalanding at nakalimutan nga niyang ibaba yung landing gear niya, ano mangyayari? Too low gear. Too low gear. Too low gear. Sasabihin niya, mababa ka na daw. Yung landing gear mo, kailangan mo na daw ibaba. So, ganun yung ano niya. And paano kung na-penetrate pa niya yung second layer ng envelope natin. So, it's not only the too low gear, but it can give you too low terrain. Too low terrain. Alright. So ano gagawin natin? Eh siyempre kailangan nating i-maneuver yung aircraft natin para ano. Kaya ito, na-penetrate niya. Eh di low terrain siya ngayon. So ano gagawin? Kailangan i-recover niya. Ayan. So ito naman to low gear, para mawala yung to low gear, anong gagawin niya? Eh di bababa niya yung landing gear niya. Alright. Until the landing gear is set to down position. And then after that, it will silence now your number 4, mode 4. Alright. Yan. So kapag binaba na niya, alert is now inhibited because the landing gear is down. Or it can be also when the flaps is down. So kaya nga dalawa to. Kaya 4B provides protection when the gear is down and the flaps are not in the landing position. But nakita nyo kanina, mga kapatid, meron kayong dedicated switch. You can still inhibit specifically flaps. There are some pilots na hindi sila nagbababa ng flaps, dire-diretso lang. So maybe they have this their own purpose as stated in the procedures, but you can still inhibit that by placing the switch to off position para wala na kayong too low flaps. Too low flaps. Alright. Yan. Too low terrain. Alright. So, yeah. Yan, ito yung sinasabi natin kanina. You have disables landing with flaps not set for landing without triggering the warning. Anong gagawin nyo ngayon? I-place nyo yung flaps to override position. So if that's the case, wala nang tunog. Kahit hindi naka-flaps flaps configuration during landing. May mga pilotong ganyan. They can inhibit. Pero hindi pwede yung landing gear. Siyempre, hindi pwede yung landing gear. Kailangan yung landing gear, pag bumaba ka, kailangan mo talagang ibaba. If not, you will have the too low gear. Too low gear. Alright, so when all conditions are corrected, binaba na yung flaps, binaba yung landing gear, then the sounds ceases. So we have also this number 5 now. Ito naman, the number 5 is descent below glide slope. So sabi natin kanina sa ILS system, you have the glide slope, and the correct angle of descent is most likely 3 degrees, something like that. But example, if the aircraft is too low within the prescribed angle of descent, then you will have your glide slope, glide slope, glide slope. Gumagano naman siya. Alright, kasi bakit? Baka kasi maging undershoot, ma-undershoot ka. Iba naman yung istorya kapag yung aircraft is above, nasa taas naman yung yung taas, mas nasa taas yung aircraft. Ano naman ang mangyayari doon? Undershoot naman siya, overshoot naman siya. Yeah, overshoot siya. Kaya kailangan yung aircraft natin must be in the correct angle of descent. Alright, so if penetrate mo, yan na, bumaba siya. Eh, anong gagawin niya ngayon? Ayan, magti-trigger na yung warning, glide slope, glide slope. As you decreases at hindi mo maiko-correct, anong mangyayari? Mas bumibilis yung glide slope sounds niya. Alright. Ayan, so increase, higher rate and volume, mas lumalakas pa pati yung niya. Glide slope, ganyan. Pero kapag nasa medyo mataas pero penetrated yung aircraft natin doon sa lower than the glide slope, then it's a soft voice. You have a soft voice. Glide slope. Pero kapag na-penetrate niya, it will increase the volume of glide slope, and even the rate. Mas mabilis siya at saka mas malakas yung sound niya. Alright. So ito, anong gagawin natin? I-correct natin yung flight natin. So kapag na-correct natin yung flight at all warning stop as soon as the normal descent path is again intercept. So this alert can be inhibited below 1,000 feet by pressing one of the GS post button switches. So ito, GS. So if you press that one and the aircraft is below 1,000 feet, it inhibited your glide slope. All right. So we have also this one, descend below minimums. All right, descend below minimums. So you set the DH kanina, di ba? How can you set the DH in the EPIS control panel? You have the DH test. So you place that one and then you rotate and you can find the DH. Where can you find the DH? It's located in the left lower portion of your EHSI. So EADI, I mean, ADI. So once it can be decision height, it can be set up to 10,000 feet and within 50 to 10,000 feet. All right, 50 to 10,000 feet. All right, so anong mangyayari ngayon dyan? So, edi bibilangan ka uli. Yan, minimums as the aircraft reaches the selected decision height. Then you have now the minimums. Meron pa ngang mga iba eh. Example, just to, meron pa ngang 100 above. Maybe the distance here is 100. Then most likely bibigyan ka ng 100 above. But once the aircraft now reaches the selected decision height, then it can give you minimums. Eh paano kung pababa ng pababa until paland? So bibigyan ka ngayon ng distance. Example, 100, 90, 80, 70, 60, 50, 40, 30, 20, 10, retard. So yun yung mga maririnig natin which is generated by the system. All right. Okay, so component location, guys. So we have the PWS GS post button located doon sa captain and FO sides natin. Yeah, captain and first officer panel. Yeah, so GS kapag you are below the glide slope. So iilaw ngayon yung GS plus caution plus single chime and the EGPWS doon sa ating CAP. All right, and of course the glide slope message trigger. All right, and of course the oral warning. Glide slope. And paano naman to? DPWS, red legends illuminates for captain and FO, and yan. Doon sa number 2 yung excessive terrain closure rate. So normally terrain lang, di ba? Pero once the pilot continues to fly and enter doon sa flight envelope without protection, then it creates whoop pull up. Whoop pull up. All right. All right, and finally, yeah, after correction, then the GPWS legends extinguish. So as soon as the post button switch is released, the GS legend and the GPWS fault lights extinguish also. So clear na siya. All right. So how about this one? The self-test or the self-GPWS in-flight test can be performed above 1,000 feet with landing gears gear up. So the audio level decreases by 6 decibel during self-test, and the test sequence in flight is the same as doon sa ground. All right. So ang ating computer, mga kapatid, is powered by 115 volts. AC bus number 2. So it's from the system number 2. All right, and the computer can be tested using the captain and FO post button. All right, so we have this one, captain and the FO push button. And what happened during test? So you can see the GPS fault lights illuminate in the CAP. Nakita nyo kanina, di ba? Meron kayong GPWS dyan. In case of, in case of loss of radio altimeter, maybe you lose the radio altitude, the altitude rate signal, radio altimeter track monitor, your computer input, AC input, computer reference signal, gear switch or flap switch, then you can find the GPWS fault doon sa ating CAP. Yan, sa ating CAP. And also, detected baro reference or rate fault inhibits mode 1 and mode 3. So, and the altitude gain default of mode number 2. So, this fault display in the aircraft, ganon din. GPS fault pa rin. Inhibit all modes and are displayed on the aircraft GPWS fault lights after delay of 5 seconds. All right, plus minus 1 seconds. So you can find the GPS fault on those instances. All right, so where can you find the GPWS? It's located in between your 80 and 83 VU. All right, so yan yung PWS natin. But there is also another GPWS. That is the enhanced mode. So stop tayo dito and tignan natin yung enhanced mode ng inyong GPWS. Kung inyong normal GPS mga kapatid is it can process 6 modes. Ano naman yung EGPWS natin? Diba? So most likely it's the same. It's just an additional information. All right. And upgrading of the system. So kaya nga ang tawag natin doon sa enhanced ground proximity mga kapatid is the TAWS version. Yan na ngayon yung TAWS natin. Terrain warning, terrain awareness warning system. So we have a new set of GPWS. We call that as the EGPWS now. It's the enhanced version. And as you can see now, this EGPWS is conform with the TAWS. Yan yung binabanggit natin, the Terrain Awareness and Warning System, enhance the basic GPWS. So this TAWS ngayon at saka yung EGPWS ninyo are synonymous. Sometimes the aircraft is equipped with EGPWS, but sometimes it is also equipped with TAWS. But there is also a possibility mga kapatid that this EGPWS and TAWS are now integrated into one unit. Ano ngayon ang tawag niya? Yan na ngayon yung binabanggit natin kanina, T2 CAS. Alright, that is now the T2 CAS. Maybe you are looking for EGPWS, looking for TAWS, hindi nyo mahanap, pero may nakikita kayong T2 CAS. It means to say, mga kapatid, yan na yung integration between the two components, the EGPWS and TAWS. Kaya nga, T2 CAS, ano it's the terrain. Kaya nga, terrain and traffic collision avoidance system. Alright, ganun yung system niya. Alright, so, tingnan nyo, I think talagang ako doon sa 5 talaga pero doon sa natin kanina, it conforms to 6 modes. Anyways, so the basic GPWS function is 1 to 5. But because the system is something like enhanced, it incorporates additional modes or improve additional modes. So like your, you have now the altitude and call outs. So nabanggit ko na to kanina mga kapatid, altitude and call out. So example, 100, yung mga ganun, 90, 80, blah, 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 blah. 10, retard. That is the updated module 6. And also, number 4, module 4, updated envelope and oral. And of course, you have also additional 2 to make it 7. Kaya nga 7 lang eh. Ayan. Inherent kasi yung iba doon sa ano. So we have 2 additional doon sa ating enhanced. That is the terrain awareness alerting display and your terrain awareness floor. So this new function use information, the position and altitude provided to the aircraft and the terrain database is stored in the GPWS. So you need to update also the database of your EGPWS para mabasa niya. Kasi ang system ngayon mga kapatid, we are not only talking about terrains now, but also man-made structures. These man-made structures can also be considered as a terrain. So example dati, ewan ko sino yung mga nakatira dyan sa ano, sa BGC. Ang daming mga malalaking building dyan. Eh nandan din yung approach ng ano yung 0624, di ba? Eh pag dumadaan dati yung eroplano noong hindi pa updated yung database niya, tunog ng tunog talaga yung eroplano, pero binabaliwan na lang ng piloto kasi hindi naman siya considered talaga kasi alam niya personally na yan yung mga building at medyo malayo-layo pa ng konti along the approach. So anong ginawa nila? Updated yung terrain database ng EGPWS. From there, wala na. Pag lumalapag na yung aircraft yan sa BGC, hindi na siya tunog ng tunog because of the updated database ng inyong EGPWS. All right. All right. So ganun din mga sirs, it's just an additional features doon sa ating EGPWS. Ano yung additional features? Yung yung terrain awareness alerting and display and the terrain clearance floor. But the overall concept and is still the same like the old GPWS. It's just an additional system. So example, another this one, EGPWS improve architecture. So meron na kayong terrain display selection. So we have the TER. Doon sa mga 320s, meron ang dalawang push button doon, terrain on ND ang tawag doon. So once they press the terrain on ND, yung terrain is makikita nila sa navigational display. Ganon yung sa 320, but of course different naman dito sa architecture ng ating EGPWS applicable for ATR, but you still have this one. Okay, so EGPWS signal receive also information from GPS or GNSS. For DAS 500 mga kapatid, nakita nyo naman nung nakaraan yesterday, we talk about the GNSS. But for the DAS 600, they are utilizing the GPS. And then in the GPWS, they also use the weather radar system for ranging, and of course your AHRS number 1. So when possible, terrain conflict is detected, a pop-up signal from the EGPWS computer trigger now the terrain mode display on the EHSI through your symbol generator. All right. So yan, ito nabanggit na natin to kanina. So you have the 6 mode, you see. Mayroon kayong 6 modes, but normally it's mode 5 only, 1 to 5 modes. Pero meron lang kayong additional na yung descend below minimums, yung nagka-countdown siya di ba? And the additional, which is the terrain clearance floor at saka yung enhanced terrain awareness and display. All right. Ayun. So ganun din. Ganun din, parang i-go na lang natin to. So tingnan nyo na lang, ganun din yung pinag-usapan natin kanina. Punta tayo doon sa ano, yung enhanced terrain clearance floor. Dapat pala ito na lang yung inano ko na kanina. Yan, ito yung updated version ng inyong mode 4. Iba meron kayo kanina doon, mode 4 and the mode 5. But increase or upgrade the envelope ng ating mode 4. So you have now the yan, kaya AB. Kanina AB lang AB. But now we have also C, envelopes and oral alert. So active, the 4C is active during takeoff phase with landing gear and flaps, not in landing configuration. So same, ganun din, but this one is applicable during takeoff. Kanina we talk about yung 4A and saka 4B is during approach. But for this one is applicable for the aircraft during takeoff. Takeoff was flat terrain and the aircraft is outside the boundaries. So okay pa naman outside the boundaries, but if penetrates na yan, then you have now this one, too low terrain. All right, too low terrain, and you have the GPWS warning plus the sounds generated by the system. Too low terrain. But if you manage, the pilot manages to fly outside that envelope, then what happened to the alert? Of course, the alerts will be ceases. All right, so ito yung 5 natin kanina. All right. And the minimum sa yan, meron na nga call out, di ba? Meron kayong call out 500, something like that. Depende kasi sa ano yan, sa software as uploaded in the system. It can still ma-upgrade pa siya. And one of the upgrading is the call outs. All right. Now, ito yung yung additional na binabanggit natin kanina, yung enhanced terrain clearance floor at saka yung enhanced terrain awareness, alerting, and display. So these are the 2 additional modes that is integrated in your eGPWS. So dati GPWS lang siya, but we have these 2 additionals kasi enhanced na nga siya. So we have the terrain clearance floor, adds alerts to a new protection elements to the basic GPWS mode. So it creates an increased terrain clearance envelope around the airport runway. So directly related to the distance from the runway. Kaya nga, bawal po magpatayo ng mga matataas na building within the surroundings ng airport natin, specifically doon sa kung saan nagte-take off at saka naglalanding. I think meron tayong alam ni Sir Alan to doon sa runway 1331 diyan sa may Manila Bay, yung doon sa domestic natin, kapag dumadaan kayo sa may airport road, merong sa may dulo along Roas Boulevard, merong 2 nakatayo doon Di ba may gasolinahan sa kaliwa, pero pag pakanan ka papunta ka ng Baclaran, makikita niyo yung 2 building doon. Yung una na malapit sa kalsada, intersection, gumagana, pero yung medyo adjacent niya ng konti, hanggang ngayon may dispute. Dati nakikita ko ginagawa na, dati nag-aaral pa lang ako, nakatayo na yun Ngayon hindi pa meron kasing dispute yun because of the terrain clearance floor, di ba? Na medyo sakop siya ng approach ng aircraft. So bawal yung katulad din yung binanggit ko sa inyo kanina diyan sa may BGC. Anyway, BGC medyo malapit or malayo naman kasi dito sa runway natin. Kaya nga normally within the aircraft or the airport runway, mabababa yung mga structures natin diyan not to interfere doon sa natin sa signal natin. Diba? Specifically during take off and landing. So this TCF alert is a function of the radio altimeter and the GPS position relative to the center or the nearest runway in the database. Kaya nga normally na-update yung database kasi sabi nga natin kanina, we are not only talking about the terrain itself but includes your man-made facilities that is also considered as a terrain. Alright, so kapag naka-penetrate siya below, so ayan na, too low terrain. Too low terrain. Kapag naka-survive siya or something like na-correct niya, ayan, na-correct niya yung di mawawala uli yung natin, yung extinguish yung red lights illuminates when the TCF, terrain clearance floor envelope is exceeded. Exceeded na siya, nakalabas siya. All right, so we have that one also. The last one is the terrain or enhanced terrain awareness alert and display. So this one pertains to, kaya nga parating na kailangan i-update natin yung software natin, di ba? I-update natin yung software. Kasi makukuha nyo yung worldwide terrain database. So it's not only here in Philippines, but of course, maybe in some other ways that aircraft sinauli, binili ng iba, that is still readily available yung function niya as enhanced ground proximity warning system because naka-integrate yung worldwide terrain database. So anything, kaya nga sabi nga natin dito, makikita natin yung potential conflict between aircraft flight path. Bakit? Kasi nakikita nyo na yung terrain mismo. So at least alam mo, ito yung aircraft natin, di ba? At least alam mo na within a particular range, alam mo yung distansya mo at alam mo kung kailan ka ngayon tawag nito yung kukorek mo yung yung flight path mo. Alright, malayo pa lang kailangan i-correct mo na. Pero kung wala kang ginagawa, papasok ka na sa warning at saka alert. So we have the 30 seconds 30 seconds caution alert. Something like that. But tuloy-tuloy ka pa, punta ka na sa 30-second warning alert. So anong gagawin natin? Kailangan i-maneuver muna, i-correct muna yung aircraft bago pa siya pumasok sa ating envelope. Alright. So, malalaman na natin, meron kayong terrain display, terrain alerts, at saka geometric altitude. So, yan, may terrain kayo. Terrain. Hindi lang yung sound, but even visual indications. Ayan. Yun, makikita natin yan. So, terrain post button, ito na nga yung natin kanina. Terrain, so makikita nyo. So terrain data can be displayed in the EHSI. When the terrain display terpos button is selected, it replaces the weather radar display. So kita nyo, radar, RDR is radar, gentlemen. So kung in the normal configuration, if you place radar, it means to say this one is yung ating mga kaulapan lamang, di ba? Weather radar. Alright. But if you press it again, the terpos button illuminates. It means to say you can see now the para siyang ground mapping ganun. Instead of weather information, you can see now the terrain. Alright, kaya nga terrain. So the terrain data now can be displayed. So ito yung magandang feature ngayon ng system. So terrain data can be displayed in the EHSI provided that the terrain post button is selected and it replaces your weather radar display. So this one is radar, this one is your terrain. All right. Okay. So yeah, kita nyo, kaya nga nag-change ng kulay-kulay mga kapatid kasi it depends on the altitude of the aircraft. If the altitude of the aircraft is most likely 2,500 to 500 feet, so it changes in color. So halimbawa, nasa yung reference altitude mo is there, 2,500, pero ang taas-taas pa ng ano mo, ng terrain mo, so kukulay ano siya, kulay pula siya. Or kapag altitude reference is 1,000, nagiging yellow siya. And then nagiging nag-change ng kulay. Ngayon kung mas mataas yung eroplano kaysa sa terrain, so kaya nga may nakikita kayong green. Or kung mas mababa na talaga, up to negative 1,000 to negative 2,000, yung taas ng reference altitude ng aircraft nyo, it can also, yan, ano siya, magiging, ano na siya, black na siya. It can even give you black. So itong mga black na to, eh walang problema kasi mas mataas yung aircraft natin. Pero ito naman, kapag titignan nyo yung bearing information ng aircraft is flying towards the maximum elevation ng ano ninyo, eh baka pumasok siya sa envelope, then it can trigger an alarm. Example for this one, malayo pa lang mga sirs, pero meron ka ng visual indications na terrain. So as you go on and without any maneuver to correct your flight path, maybe it's not only the visual indications now, but to include also your oral alerts. Terrain, pull up. Whoop, whoop, pull up. So something like that. All right. So you see, reference altitude is projected down from the actual altitude and to provide 30 seconds advanced display of terrain when descending for more than 1,000 feet per minute. So advanced, 30 seconds advance. So at least makikita mo na. So maganda pag pindutin mo yung terrain. Yeah? Pero kapag weather radar lang tayo, pindutin mo yung radar lang. So it's just the weather precipitation. But if you press that pause button, terrain pause button, then it can give you the terrain database. All right. So these are the presentation. So kung green lang naman siya, eh kayang-kaya niyang lampasan, di ba? Kayang-kaya niyang lampasan. Okay, ano pa? Alright, so yeah, kapag ano naman, papalapit ka ng papalapit, sabi nga natin, wala mo ng problema, malayo-layo pa eh. Makikita mo, most likely yung train is most likely nasa 30 to 40 nautical miles away from your aircraft. But as you go on, flying towards the obstacle, eh siyempre papalapit kayo ng papalapit hanggang sa ma-penetrate nyo yung flight envelope. Malapit na. So, most likely around 10 nautical miles na lang mga kapatid. Yung pinaka-peak natin is nasa 30 nautical miles. So if that's the case, terrain, tapos magbabago na yung kulay ninyo. Ayan. And GPWS, lights illuminates, and the oral alerts. Caution terrain, caution terrain. Eh paano kung palapit ka pa ng palapit, na penetrate mo na yung obstacle. So what happened? Of course, terrain, pull up. Terrain, pull up. Makakarinig ka na ng it's not only visual but also oral. So anong gagawin natin? I-correct natin yung path. So kapag na-correct natin, edi mawawala na yung mga alerts natin. Alright. So yan ngayon, nangyari yan sa Cebu Pac, yung DC-9. Akala niya, ulap lang, bundok pala. Pero ang nagkamali niya is noong kinorek na niya, it's not enough. Hindi na siya enough yung sa bilis ng eroplano at saka yung distance niya na is most likely cross proximity. Kaya nga nung saan bumangga yung eroplano, actually doon sa pinaka-peak ng bundok, kaya nahihirapan yung mga rescuer during that time. Ganon yung ano. Pero at least we have this kind of technology to warn yung ating mga piloto. Ayan. So GPWS system, and this GPWS is yan, an help coming from an input coming from the GPS, an input coming from the radio altimeter, and the terrain runway elevation. Anong ibig sabihin ng ano nito? Terrain, that's why you have the database, terrain database. All right. Okay, so I think this one, alam nyo na to. Test, kapag prines nyo yung GPWS, GS post button, anong mangyari, and hold it, then it can gives you the alerts. So visual at saka oral alerts. All right. Then 1 second later, the GPWS or the GPWS illuminates also, and you can hear now the whoop whoop pull up. All right, and finally extinguish. So ganun lang mag self-test, and the GPWS flight test is above 1,000 feet with landing gear up. All right, so same applies kanina yung test doon sa GPWS. It's the same function like in the EGPWS. All right. So terrain naman, yan, terrain mode is ready selected, and the radar control is selected to standby. And anong gagawin nyo? Press and hold yung GS post button. Yan. And hold it. So after that, the GS lights illuminates, may mga terrain na kayo, mga fault. Yan. And GPWS fault doon sa inyong pangalan nito sa CAP and single channel. And yun na nga, meron na kayong yan, yung glide slope ninyo may X siya. Something like that. So to test the informations presented in your GPWS test. All right, so ayan, mga makikita nyo. Follow-up oral message are triggered pull up. Yan, and yan, sync rate pull up. So lahat ng mga sounds maririnig nyo. All right. Maririnig natin yung mga oral messages. Yan. So after that, it will disappear. So if GPS boost button is pressed less than 3 seconds, short test sequence is activated. All right. So ganyan yung ano natin, yung EGPWS natin. Same lang din lang naman yung architecture dun sa GPWS versus EGPWS. It's just an inherent doon sa ating EGPWS and additional modes. Yun lang naman yung pinagkaiba niya. Additional modes. So same locations is in 83BU. All right. So that is our EGPWS. All right. I think we need to have a break now, mga kapatid. So i-continue natin to mamaya, at ang sunod na topic natin is yung ILS. Kunti na lang to. ILS at saka marker. Dalawang topic na lang. Alright, and then after the 2 topics later, we'll start your structures. Maliit lang din naman yung structures natin. Alright, so I think we need to have a break. So please be back, mga kapatid, at 7:03. All right.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir. All right, good evening, everyone. Can you hear me loud and clear? Test mic, 1, 2, 3. So are you here present now or still, okay, maybe we can stand by for 5 minutes and then we can start our second session this evening. All right, so stand by for 5 minutes, gentlemen, while waiting for others.
Copy, sir.
All right, good evening, everyone. So we can start now the second set for this evening. So we still have last topics for navigation, and then we can. So this is the principle of the operations of your ILS system. Actually, your ILS system is comprises of 3 facilities. Normally, it is only the localizers and glide slope, but to include also the marker beacon. All right. So the purpose of this ILS is to allow the aircraft to follow the optimum descent in order to land in poor meteorological conditions. So example, if something like the visibility is 4, then most likely you rely on instruments. And as you follow the instruments, so most likely, in principle, you are being guided by this localizer and glide slope towards the center line of the runway, that is your localizer, and the glide slope giving the aircraft the optimum descents we see within the correct angle of descent, which is 3 degrees. All right. So this ILS enables the angular deviation between aircraft patch and the glide slope. So possibly you can rely on the indications which can be located in your EADI as well as in the EHSI. All right. So angular deviation with the aircraft flight paths and runway alignment. That is the localizer beam. So you are flying along the extended center line of the runway. All right. And you have the transmitter. Of course, we have the transceiver. You have an antenna that send the. Of course, you need to. Of course, the system is tuned to a correct frequency, which is 108.1 to 111.95 megahertz, and your glide slope is 328.6 to 335.4 megahertz. All right. So the ILS system is considered as a dependent position determining system, although it is considered as a landing aids. All right. Okay, so this is now your EADI, in which you can find the information regarding the localizer deviation and your glide slope deviation. So this presentation is a full mode, but it can also be in art mode. So it depends on the choices made by the pilot. All right, so this is the art mode now of your EHSI. So it can be rose mode. This is the rose mode, 360 degrees, and you have also the art display. All right, but still it can present localizer and the glide slope deviation. All right, this is also another information. It's located in the EADI, so that's why both EADI and EHSI displays the information for your localizer and glide slope. So in the EADI, you can find the localizer also, and of course the glide slope. And to include, gentlemen, we have now the information of your marker beacon. So as you can see, it's I. So it means to say that is your inner marker beacon. All right. Okay, so this is how the system works. So we have two antennas, the glide slope antenna, which can be found in the radome just adjacent to your weather radar, and in the vertical fin of your aircraft tail, in the vertical stabilizer, you have the Vorlock antenna. So that is the localizer and the glide slope antenna, and as soon as they receive the beam as projected by the localizer and glide slope, those signals now are sent to your VOR localizer transceivers, or okay, VOR ILS marker receiver 1 or 2. Yeah, 1 and 2. And that one now is being processed by the system and send that information to your SGU 1 and SGU number 2. And from there, the SGU now will send that information to both our EHSI and to our EADI information. As we indications as we see in those indications. All right, so yeah, the glide slope and localizer sent to your VOR ILS marker receiver, and through your SGU, it sends now to your EADI and EHSI for indication. All right, so yeah, you need to control you need to tune this frequency, right, of your ILS system in the knob control box. All right, so when either pilot is using this control unit on the ILS frequency corresponding to VR needle on the RMI, parks at 3 o'clock position, they will go to 3 o'clock position. All right, and then ILS information, of course, sent also to your FDAU. See this one? FDAU for recording purposes. All right, and yeah, a communication between the symbol generators and your AFCS, it's through your ASCB, Avionics Standard Communication Bus. All right, because if something like the aircraft is in auto flight, all right, and as we all know, the aircraft, gentlemen, is category 2. So most likely along the approach, you can what do you call this one, track and capture, capture. So you can see the glides localizer first with asterisk, something like that. And then after that, if it is tracking now, you can see that the localizer now is green, no more asterisk. It means to say tracking. So this system, gentlemen, the localizer is or the glide slope is interlocked with your localizer, meaning localizer first before glide slope. So after the localizer, here comes the glide slope now. So if it is capturing, then you can see glide slope with asterisk. But after capturing and tracking, that signals now produced by the glide slope beam, then you can see now the GS in green only. And if something like the autopilot is engaged, then the system will just follow the beam. And what the pilot do is just monitor those indications. But then after that, because of the decision height, most likely the pilots now will disengage the autopilot system and the pilots will manually control the aircraft in landing. So what they do is they will now align. They will align those informations for localizer and glide slope and maintain them. So that the aircraft can land safely on ground. All right, so your system also is sent to our GPWS. Specifically, if you remember, gentlemen, the mode 5 of your GPWS. What is that mode 5? That is your glide slope. All right, that glide slope is integrated to GPWS. All right, and of course the RCAU. So once you tune to a correct ILS frequency, so you can have a tone of voice, right, which conforms with the station identifiers, and that one is of course generated by the remote control audio unit. All right, and then of course you have two systems, is it? Your VOR and ILS. So in normal configuration, so no worries because they're working. Yeah, they are working together. But in cases maybe that there is failure in the switching panel, you can still utilize the VOR ILS for the FO side or for the captain side. So and of course the remaining VOR ILS receiver will give the information, the remaining source, using this VOR ILS post button as you manually press them and manually select them. So it's redundancy, gentlemen. Although you lose one receiver, no worries, because you still have the opposite operating side. All right, and of course, see this one now. Example for this one, maybe you lose your transceiver number 2. All right, you lose your transceiver number 2, but you still have the transceiver number 1. And what you can see here now is FO, and the FO now is using the receiver number 1 or the system number 1. So received by the VOR localizer, sends a signal, and it's sent to your SGU. And see now this one, guys. The SGU will send the information to your captain side. But as you can see here, you have the ASCB bus. So, and allow the signal coming from the symbol generator number 1 to transfer in your symbol generator 2. It means to say the symbol generator number 2 is a slave of your symbol generator number 1, and that information coming from the symbol generator number 1 is now sent to your FO side. All right, so that's the purpose of this switching switch. All right, the switch. All right. So when the captain post button is pressed, all the HSI NDI are connected. You see now, connected to the FOVOR ILS marker receiver through your ASCB. So the FOVOR ILS switching post button is inoperative in this configuration. Priority now is given to the captain. So if this is the other way around, so this one is faulty, but the number 2 is the priority now. So that's why you can see the captain now. Captain, priority is captain, and the FO is using the system number 2. So that's also the same configuration. So it goes to your symbol generator number 2 and distributed to the captain display unit, and through your ASCB bus goes to your SGU number 1, and of course it goes to supply your captain display unit. All right. Okay, so you have your control box to select the ILS frequency. All right. So if the ILS frequency is selected, the test can be performed without signal reception. So you can just press the test. All right, so you have also this 3-position rotary selector. So you can turn off, you can turn on, or you can hold. All right, so yeah, ILS is now power supplied. You set it to on. The active frequency, being the ILS frequency, can now press the test button. So you can now press the test post button, and what the test can do is to assert if the plugs of the glide slope and your localizer is present, red crosses, or at least to determine that the indication is working properly. All right, so and then the red crosses disappear, and then the lateral deblation moves to 2/3 scale. So you see this one now, they are now in the 2/3 scale, same as well in the glide slope, 2/3 scale. All right, and in the EIDI also, red crosses also for localizer and glide slope. And then after that, same also, it goes to the 2/3 of your glide slope and the localizer and the glide slope also. And you see now, gentlemen, your additional marker lights will illuminate. So we have the O, that is outer marker, the I, inner marker, and the M is your middle marker. All right, that is the test. All right. So if you press the test and there is no fault, then displayed in the upper window, zeros code, what do you call this one? A dashes, 4 dashes in the upper window, and there is no fault code, 0, 0. But if there is fault, then you can see flagged and the fault codes. So look in your FCOM now, what is 05 fault code, and do the interpretation. So for this one, example for this one is diag 14. So what is 14? Unit is unstable because of the power supply is faulty. At least you check now the electrical power supply, if that's the case, for troubleshooting purposes. All right, so there's a lot of codes. Okay, and the receiver will return to normal operation after 15 seconds, even if the test post button is held. As long as 15 seconds, you press that one, after 15 seconds, goes back to normal operation. All right, so yeah, that's how our ILS system works. All right, and of course, we have the last topic now for our navigation system, your marker beacon. Okay, let me check this one, the components for your ILS system. All right. Okay, so these are the components now, gentlemen. So where can we find the glide slope antenna? All right, so it's located in the radome. All right, radome. All right, you see this one? It's just below your weather radar antenna. So if you remove the radome, you can expose the weather radar antenna as well as the glide slope. And of course, our Warlock antenna, it's located in the vertical fin or vertical stabilizer. All right, Warlock antenna. So this is how it's connected. And the computer for your VOR ILS marker receiver is located in 83 VU, and the number 2 system and its power supply is powered by standby bus. But for the receiver number 2, it's located in 82 VU, and it is powered by the normal bus, which is your DC bus number 2. All right, so this is where you can find your ILS receivers. So 82 and 83 VU. Okay, so that's all. Okay, next is the marker. All right, you still have marker, and anyway, the marker, gentlemen, has been actually discussed through your ILS system. It's considered as a facility of your ILS system. These are landing aids. All right. Okay, so yes, we have your localizer and the glide slope that has been discussed in your ILS system, but as you can see, there is now an integration of additional facility for ILS called the marker beacon. And yeah, we have 3 marker beacon. So normally your outer marker beacon is most likely indicating the distance away from the threshold of your runway. So most likely around 5 to 7 nautical miles. This one, your inner marker is most likely 2 nautical miles, and the inner marker beacon is most likely 100 meters away from the threshold of the runway. But something like the distance, gentlemen, may vary depending on the airport. Actually, in some airport, you cannot find this marker beacon, especially if the approach is within the sea, something like that. You cannot observe them. But in some instances, yes, there is. So all these marker are being replaced by the ILS DME system, maintains many parts of the world. So this function is to provide indication to the flight crew that the aircraft positioned with respect to the ILS descent axis. So 3 marker beacons are available, and you see, located at known distance on the center line of the runway. And each marker beacon has a frequency of 75 Hz. So it means to say, gentlemen, this marker beacon produces a pan-shaped signal as soon as the aircraft passes through its marker beacon. It gives an indication. So you see the indications earlier. It can be outer, O, M, middle, or I, inner. And as long as you passes through the given marker beacon, you know your distance away from the threshold of the runway. Yeah, so see, when passing through its beam, it causes audio and visual information. So what is this audio? So most likely, if you passes through your outer marker beacon, it produces a Morse code signal. Dashes, ta, 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 something like that. And after passing through, becomes silence. And then after passes through its middle marker beacon, it's an alternate dot and dot, dash and dot, ta, 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 something like that. And then after that, passes through, after passing through your middle marker, it's silence. And then after passes through your inner marker beacon, it can give you 6 dots per seconds. You can hear those, what do you call this one, audio or Morse code audio signal. All right. And of course, for indication, you can see O, you can see M, or you can see I. All right. Okay, so yeah, marker beacon. So you have the informations to be presented in your EADI. All right, so you can, okay, so you O, M, and I. And visual display is coupled with corresponding audio. All right, and you have the 2 position switch for your marker. This is your sensitivity. All right, receiver sensitivity. So if it is low position, normal position is in approach, but high position increases the receiver sensitivity so that the beacons can be detected at high altitude. All right. Yeah, so this is how the system works. So you have a single marker antenna, which is located in the belly pairing. And you have a coupler. Why coupler? Because you have 2 receiver. So it will split. So this antenna coupler now will split that signal and send that information to your marker receivers. All right. Okay, so see this one. You have that one. All right, it will split to your number 1 receiver and to your number 2 receiver. And after that, it will send a signal now to your symbol generator unit. And from the symbol generator unit, you can now find the information of your marker beacon. All right. And there are some also other interfaces, of course, sending information to your FBAU, the 3 marker beacons for recording purposes. All right. And of course, we have the high and low. In normal, it's low, but high sensitivity, you place it to high position if the aircraft is at higher altitude. And of course, that information now sent to your ILS. And if they tune to a correct frequency, of course, you can hear also some station identifiers. All right. That's why you see it's it interfaced with your RCAU. All right. Okay. So in your control box, so we have the marker to be tested automatically when the test post button is pressed. All right. So in the unit, and either viewer or localizer frequency is selected. So as soon as you place it to on and press the test, what will happen? So when the test post button is pressed, the active and the preset display intensity will modulate to minimum to maximum to indicate the test. So something like it will decrease the intensity of light, and then it will goes back to maximum indication, the illuminations of your display unit. And then if no fault is detected, you can hear a 30 Hertz tone from the RCAU, of course, via your loudspeaker. And then you can find now the in the EADI, you have now the 3 indicators, whether the O, I, and M in the EADI. And of course, you can see the 4 dash and 00 if no fault is detected. All right, but if something like maybe you have fault as detected, then you can find the diag and of course the fault code, which is 32. All right. So 32 indicates that fault has been detected in VOR or ILS system. So you can see that in the FCOM. And then after 15 seconds, even the test post button is held, it will back to normal. All right, so this is now your marker antenna, which is located in the belly of your aircraft. And you have now these marker antenna couplers to be distributed to your 2 receivers, receiver number 1 and your receiver number 2. All right. And the receivers, gentlemen, number 1 is 83 VU and powered by 28 DC standby bus, whereas the receiver number 2 located in 80 VU and powered by 28 DC normal bus. This is DC bus number 2. All right, locations. Okay. So I think this is the end of our navigation system. All right. Is there any question, guys, relating to your navigation? So we have a lot of navigations facility. I think this is one of the longest topic that to be discussed, even in some other aircraft. The navigation system is heavy topic. All right. Okay, now we go to your structures now. Okay. Structures, gentlemen. This is our last topic for this evening. All right. All right, now this now is your structure. Yeah, of course, our aircraft, specifically the make of our aircraft, is composed of different materials. Some materials are metallic. That's why you have a alloy, steels, and titaniums. But as you can see in the notes, gentlemen, it's not only a metallic parts, but also a non-metallic parts, which comprises of composite materials. So as you can see, those different colors, gentlemen. So example for the red, the amber, the green, the blue, and the yellow, those are non-metal parts which conform with this what you call composite materials. So in those in this presentation, gentlemen, or reds are carbon nomex sandwich. Those ambers are carbon monolithic structures. The green, gentlemen, which are most likely located in the leading edges and even in the landing gear fairings, the doors of your nose landing, and of course even your radome is made up of Kevlar. So when we talk about Kevlar, gentlemen, that is something like a ballet twitch with stiffening carbon fibers. So it's again another Kevlar in the intake clip of your engines, cowling and nacelles. All right, and of course you have also the fiberglass Nomex sandwich. So if you remember, gentlemen, in the navigation, you have your flux bulb. The flux bulb, we can find the flux bulb located in the edge of your wings. Why? Because the wings, gentlemen, is most likely around, shall we say, 80% made of the wings is composed of composite materials that has no magnetic effect on the flux bulb. That's why those flux bulb is located in that position, so that no magnetic interference in those flux bulb, because the wings is generally made of composite materials. All right. All right. So yeah, we have a lot of metal. You have the alloy, light alloys. All right. You have the 2024 clad or the 7075 clad, or it can be 7010 clad. All right, we have also steels, and we have also titanium. All right, so we have the alloys are generally subjected to surface treatment. So we have the aluminum alloys, so electromechanically iodized, and we have also your titanium alloy, which are generally not protected unless when it in contact with different materials. And you have also the steel. All right, so they are generally cadmium clad plated. All right, so these metallic parts of the structures are protected against corrosion with clad shields, allodyne and anodizing treatment on bare aluminum and primer enamel and facing sealant on the critical areas. So special treatment are used when the different materials are in contact, because since you see these metallic materials, gentlemen, they have different properties, and the tendency, if they are in contact to each other, what happens? It causes corrosion. So of course, we need to protect this one. We need to protect, especially maybe here in the Philippines, we are flying the ATR inter-island, and we are passing through seas, and it causes salt water that can alleviate the generation of corrosion to your aircraft also. That's why they are being treated. All right. So non-metallics, we have also the non-metallics now, generally composite, which is an assembly of aligned fibers bonded together by an organic synthesis resins. So mainly used fibers are the fiberglass and Kevlars and even carbons. So composite use on the structure is divided into groups. We have the carbon structures, the Kevlar Nomex sandwich, and the fiberglass Nomex sandwich. So in most cases, composite material cold repair is possible. So the detailed instruction will be given in the applicable maintenance documentation. So you can do repair for this one. All right. Okay, so structures present with several types. Sometimes in the structures, gentlemen, they are being joined together by rivets. Generally, aluminum alloy or Nomel for particular cases. Some, they are permanent bolts. So it's high-lock fastener, aluminum or steel nuts. Some are removable bolts according to standard torque set by high torque. So removable, it needs to be torque. All right, we have also your torsion bolt, high resistance stainless steel or in-colonel bolts, and some are banding used for metal connection. So if two joint materials, what happened in order to of course there's still a formation of corrosion, but to lower down the process of corrosion, what they do is they band together the metal. All right, and the tendency sometimes the bonding wire, gentlemen, is especially the bolts, you can find some corrosion there, right? And sometimes it's very hard to remove. All right, some removable bolts or breeze, something like that, and you need a special tool in order to remove those removable bolts or permanent bolts. All right, so structures parts are generally painted. So we have the primer loaded with chromate for a better resistance to corrosion, and more especially to skydroll and fuel. Of course, sometimes we cannot deny the fact that during the servicing of your hydraulic system or even refueling, there are some spills, and this skydroll and fuel can actually harm the properties for our structures that can cause corrosion. All right, so we have also the polyterene retain enamel for better adaptation to surface strains and vibration, hence better resistance to corrosion also. So, but there are components of your structures that are unpainted. Example for your P2 static system. Why? Because this one, gentlemen, is heated. So what happened if you paint them? It just melt down, and those paint can cause blockage to the opening of your P2 static system. That's why it cannot be painted. We have also the triangular plates indicates in the fuselage datum and other labels, the seals, your static dischargers, coupling areas, and the horns. The horns also cannot be painted. Why? They are also heated electrically. All right. So yeah, that is the interface of our structure system that comprises your fuselage, the wings, stabilizers, nacelle, windows.
Police.
All right. Okay. So major advantage, guys, of the composite versus the conventional material is, of course, lighter. So it saves weight, but the strength is still there. Yeah, high mechanical strength, materials optimization, and the maintenance cost. Yeah, fatigue, strength, and corrosion free. That is the advantages of having composite. And as you can see, the composite materials, gentlemen, that is present in the ATR aircraft are most likely those of flight controls, right? The doors, the radome, the cowlings, right, and the belly fairings. Those are the most likely made of composite materials. All right, so yeah, see this one, these are fibers. All right, and unidirectional tapes or fabric types. And of course, they are banded together with resins. So two kinds of basic design. So we have the sandwich structure and the monolithic structure. All right, we have this one, sandwich structures consists of two composite skin banded with a honeycomb core. So inside, gentlemen, that is the honeycomb core, but you have the what do you call this one, composite skin. So composite skin, something like it is covering your honeycomb core. That's why called sandwich structure. All right. So, and the sandwich structure manufactured in two process. We have the multi-phase process or the co-curing or single-phase process. So it depends. So in doing the repair, please refer to your proper documentations, your structures repair manual, SRM. All right, so we have also two types of monolithic structure. We have the multi-rib box monolithic structure. So the box consists of non-stiffened skin monolithic panels supported by multi-spar or multi-rib structures. All right. And you have also the integrally stiffened monolithic structures. So consists of integrated stiffened panels supported by spars and ribs also. All right, and you see this one, there is a no step area. If we are going to see the wing structure presence in the wings, this one. All right. So stepping beyond that line, gentlemen, you will damage the structure, specifically your composite structure. That's why you have a something like label, no step beyond that point, something like that. So do not walk outside this area, because if you happen to step beyond this area, you will step on the composite structure that, of course, can be damaged. All right. So the aim of this part, of course, supply some general concept perception to apply during maintenance operation. So the use or handling of some products is, for example, sealant, cleaning agent, compounds, even if they are not toxic or dangerous, nevertheless require particular attention. So even though they cannot harm you, better to be safe lah. That's why from time to time, if you use some sealants, avoid contact to your skin. That's why you need to place your PPEs also. All right, much better. All right, if product comes in contact with skin, wipe immediately with clean cloth, wash, and wash the interested part with water and flush. Much better. All right, so before inspection of the structure, protect the windshield and window with craft paper or sheet of plastic secure with adhesive tape, so that you cannot damage the windshield. So in particular attention for the de-icing and anti-icing in the fuselage. So this de-icing fluid, something like that, of course, that is sprayed to the windshield. If they are in contact with metals, it can cause also corrosions. All right. And when the impact zone is known, so examine the entire aircraft exterior, especially flight compartment windows, for impact damage. So, example, bird strike, something like that. You need to assess the structures. You look for different types of structures like scratch, gouge, dents, something like that. All right. So that is the first topic on our structure system. Okay, and we have still one topic, and this is longer topic to explain the better composition of the structure system of your aircraft. All right, guys, but I think we deserve a 10 minutes break, gentlemen. So please be back at 8:02, all right, or 8:05, all right. So have some break, have some UC break or wee break, all right. Please be back at 8:05, and then we continue our structure systems. All right, stand by.
Okay, sir. Yes, sir.
All right, welcome back. And this is our maybe last session for this evening. All right, so we still have 1 hour to discuss about our fuselage. So in general, gentlemen, our aircraft, specifically our fuselage, is a semi-monocoque construction. And it is made up of aluminum alloy, except some parts which are composite. So as you can see in the drawing, gentlemen, generally it is composed of metallic structure. All right, and specifically the fuselage is made up of metallic structure. But just like we've shown in the notes earlier, that specifically for the wings and the flight controls, including the belly pairings and the radome, are made up of composite materials. But generally, it is made up of aluminum alloy, that is a metallic components. All right. So the fuselage is composed of frames and panels. The frames are manufactured by 7075, the T6 materials, and they are spliced together. All right. The cross section of the frames is of C, or Z. All right, the Z type obtaining by forming. So the frames mostly stressed by higher loads are built of T70, 75, T73 machined aluminum forging. So these are the make of our fuselage. So these are the types of materials. All right. So stringers are tied to the frames, and they are made of 70-75 materials also. That is T6. And they are attached to the fuselage component by rivets and designed to withstand the compression loads to transmit loads. Right? Because as we all know, gentlemen, specifically our fuselage, the fuselage is pressurized. Something like if you may consider, the explanation is something like the fuselage is breathing. So if the aircraft is on ground, so it shrink. But as the aircraft pressurized at high altitude, becomes bigger. And of course, that's why some frames, some skin are stressed. That's why we need to build these fuselage with a very strong material. All right. And they are being made specifically for the frames and yeah, to include the stringers, all right, of the fuselage components, and they are being riveted. So they are being riveted. So as you can see in the outer skin of the aircraft, they are being riveted to its stringers. All right. So yeah, see this one. The beam runs along the pressurized fuselage. All right, so it's pressurized. All right, and the pressurization, yeah, transfer to the floor shear loads to the fuselage skin. So the beam are manufactured the same, gentlemen, 70-75 T6 materials. They comprise web and the two plates differently arranged according to the specific purpose, and the web and the plates can be integral and riveted. All right, and of course the beam is designed to mainly to strengthen the frames and the plane to support the floor panels and to withstand the shear load. All right, so panels can be of two types, the skin or the floor panels, and they are the skin is made up of a 2024 T3 skin, stiffened by 70-76 T6 riveted stringers. So these are the types of materials, or that can be connected, or that can be found in your aircraft. All right, so yeah, as you can see, the different frames, gentlemen, starting from the frame number 1, guys, frame number 1. So just to emphasize this one, the frame number 1, gentlemen, is the forward radome. All right, the forward radome. And then, of course, most likely on this area, we have now the unpressurized section. That's conform your aft bulkhead. All right, so we have different sections, section 11, 13, 15, 18, and 16 and 18 with their frame numbers. So for section 11, that conforms frame number 1 up to frame number 13. The section 13, that is your frame number 14 up to frame number 23. Your frame number or section 15 is 23A up to 29, and section 16 is from 30 or 29 up to 42. All right. And the 18 now is 43 to 48. All right, so your frame 16, guys, or section 16, I mean, on frame 42. So this is now your unpressurized. So that is now the delineation of your pressurized and unpressurized. So it means to say we have the forward bulkhead and the rear bulkhead. All right. And you see, this is the construction now. We have the C type, but you have also the Z type, C and Z type. All right. And they are being joined together by rivets or bolts, joining together with the skins of your frame, and they are riveted. All right, so this is how it looks like, gentlemen, how they are being joined together and riveted together. All right, so these are just some sort of pictures how our fuselage is being made. All right, so we have also the floor panels. Also the floor panels now. So in the specifically for floor panels in the cabin and in the cockpit. So floor panels are sandwich panels supported by 4 longitudinal beam. 4 longitudinal beam running along the forward cargo compartment, including 4 1-inch pitch attached truck and the traverse beam. The fuselage floor structure is protected against corrosion and moisture. Particular attention is paid to anti-corrosion treatment in the galley. Of course, in the galley, it's we call that a sweat galley. That's why it needs to be protected. All right, not only in the galley, but even in the toilet and even in the entrance area. So there is a probability of accidental ingress of liquids that can cause corrosion. All right, so the floor panel carrying capacity is 400 kilograms. All right, in the cabin under seats, it's 200 kilograms. And in the passenger compartment galley lavatories is 400 to 450 kilograms. All right, so yeah, the fuselage is manufactured in different sections from 11 to 18, as you can see in the pictures earlier. So section 11, that is your fuselage nose, and the section 13 is the forward center fuselage. Section 17 is the fuselage center. We have also the section 16 is the fuselage rear, center, and the section 18 is the tail fuselage or fuselage tail. All right, so I think this one has been discussed earlier. So you have the section, forward, you have the fuselage, center, front, center, and rear. And the section 18 is your tail section. All right, so another picture. So in the floor beams, so in between, gentlemen, you have 1, 2, 3, 4. So which is what do you call this one? In between the aisle. In between the aisle, we have 2 seat track on the left and 2 seat track on the right in order for you to connect the seats. All right. All right. So yeah, starting from section 11. Starting from frame number 1 up to, you see, it's 47. It's 47. That is the rear bulk cargo. Not bulk cargo, the bulkhead, I mean, the bulkhead, rear bulkhead. We have the rear bulkhead and the forward bulkhead. That conforms your pressurized section of the aircraft. All right, so our nose, specifically for section 11, that is the forward nose. So the radome, gentlemen, is made up of Kevlar with Nomex core attached with 4 quick opening latches. All right, before the frame number 1. So it means to say the radome, guys, is frame number 0, and frame number 1 is the forward bulkhead. All right, you have the forward bulkhead. All right, so you can find 4 latches. All right, to in the radome for security, and the fuselage nose section is essentially stringless construction with frame placed at half of normal splicing, and the skin is chemically milled by 2024 T3 materials. All right. So what are the components that we can see in section 11? Is the frame number 1 up to frame number 13. In frame number 1 to 13, there you can find the nose landing gear doors, nose wheel well. All right, and of course, in this area, maybe in this section, gentlemen, in the lower portion, these are unpressurized, but along the upper portion of the fuselage of the aircraft, that is considered pressurized. All right, that's why please make sure, gentlemen, if you open the avionics, forward avionics compartment door, access through your nose landing gear, the door, gentlemen, must be secure properly to avoid leaking. All right, and of course, on top you have the emergency hatch. All right, so of course you have now the floor. All right, captain and FO flight compartment, including the third occupant. All right. Okay, and then you have now the section 13 from frame 13 to 23. All right, so that is the forward cargo now, the emergency door, and part within the window. So you have the frame 13 to frame 23. This is section 13. All right. All right, so a picture of your cargo compartment. And then we have now the section 15. All right, in the section 15, extend from frame 23 to 29. So frame 23 and frame 29. But as you can see here, gentlemen, the wings, the wing fittings is located in frame 25 to frame 27. And also your main landing gear fitting. So also 25 to 27 also. So the wings fittings as well as the main landing gear fittings. All right, so this is the wing fittings on the 25 and on the 27. All right, and now you have your frame 16 that extend from 29 to 42. All right, 29 to 42. And from there, gentlemen, this is now your rear bulkhead. All right, the rear bulkhead. So what is within the section 16? You have the coat room, the galley, toilet, passenger entry, your entry with the service door in the other side, and the emergency exit, and the aft part of the passenger compartment. All right, so this is on the left hand side, you have the entry door, and on the right hand side, you have the service door. All right, so this is the entrance door. And yeah, a part of your, what do you call this one? Frames. So 29 to 42, in the lower portion, you have the from frame 38 to 39. This is still part of the section 16 below. You have the skid, and that is also the skid. You have also the connections for your tail prop. All right, the tail prop. All right, so on the other side of frame 16, on the right hand side, you have your service door. All right, and then you have now your 18, I mean 18. Frame 18 that is now extend frame 42 up to 48. So 42 up to 48. And from there, you can see now this one. You see this one? This is now your pressure rear bulkhead located at frame 44. And from there, you have now the unpressurized area. The unpressurized area, there you can find your avionics, aft avionics compartment. And of course, the attachment fitting of your vertical stabilizer. So yeah, you have the component, the materials, gentlemen, 7075, T73. So you can find the rear pressure bulkhead, the rear avionics cabinet, compartment, the tail cone. All right. Okay, and yeah, in the what do you call this one? Center fuselage from frame 23 to 29. There you can find the fittings. Is it? So you have you can use if something like you've seen the fittings for the wing fittings in that area, and of course for the landing gear, you have also this one. Same, gentlemen, we have frame 25 to frame 27. All right, same. We have the wing fittings as well as the main landing gear fittings as shown in the picture also. All right, and in that area also, from frame 24 to 28, we have your wing fuselage pairing. All right, that is the wing to fuselage pairings also. And not only that, even the main landing gear fairing. So it is placed around the zone. And connection panels are manufactured using composite materials. So that is composite materials also. So how about in the main landing gear? So in the section 15, panels are manufactured by Kevlars also. So this main landing gear fairing or belly fairing is made up of Kevlar Nomex sandwich. So of course, in that area, restores the aerodynamic profile of your main landing gear and contains components relevant to air conditioning, hydraulics, and lighting system. So if you want to access all those things, then you need to remove these panels. So why Kevlar, gentlemen? Because as we all know, the aircraft is lowered, and there is a tendency that FOD may come and of course damage the system. So much better if the system are covered with Kevlar. So something like bulletproof, cannot be easily penetrated by types of any types of FODs. All right, and of course we have now the wing connections. Wing connections, guys, on frame. What is that one? Frame. Wait. Frame 25 to 27. Frame 25 to 27. You have now your wing. All right, wing box, something like that. So a rectangular center box with two trapezoidal outboard boxes, one for each sides in the center wing box. So this is the center wing box, but on the end of the center wing box, you have now the two trapezoidal outboard boxes. So this is your center wing box, but at the end you have now the trapezoidal outboard boxes, left and right, and of course there are interface to your center fuselage through your frame 25 and 27. All right. To this one, frame 25 and 27, that is the wing fittings. Right, this is now the wing fittings, gentlemen. All right. All right. So these are the wing fittings, which can be found on frame 25 and 27. All right, and you have these for the frame of your wings. So we have the wing box, center wing box, from starting from the center. That is the center of the fuselage upper part, from 0 up to 13. That is your center wing box. And from frame number 13, we have now the trapezoidal outboard box. All right, so from 0 to 13, left and right. So example, this is right, and this one is on the left. All right, so this center wing box upper surface includes one panel, two center removal panels, and one rear panels. So lower structure includes one single panels, one center panels, and one rear panels. So from rib 4 to 13. So if we count 1, 2, 3, 4. Okay, so this one, that is rib number 4. That is 4 to 13. This is number 4. All right, 4 left, 4 right. That is rib number 4. Left and right contains the fuel tank. All right, so this one now. This is now your fuel tank. All right, for rib 4 to 13. That is your fuel tank. All right, the center box comprises of two spars. So we have the front spar and the rear spar. All right, rear spar. Okay. So sealing fastener and sealing materials are resistant to the approved fuels. So all aluminum alloys part forming the tank structure, internal structure are vacuum blasted, iodized, and painted before assembly. All right, so the wing center box includes the leading edge. So this is now your front spar leading edge and the rear spar, which is attached to your leading edges. All right. All right, and of course, the front spar now, we have now the leading edges. And of course, on the rear spar, you have now the connections of your inner and the outer flaps. All right. So, and then after that, after the rib 13, it goes up to rib 30. And of course, that conforms your trapezoidal outboard box from 13 to 30 trapezoidal. So it is built the same way with the center wing box. Joined together is rib 13 to 23 by 8 traction bolts. And yeah, as part of the right and the fuel tank and the surge tank. So example for this one, 13 to 23 is your outer tanks. All right, the outer tanks. And your vent surge tanks is located 23, 24. This is your surge tank. All right. That can be your surge tank. 23 to 24. All right. So its outboard wing box includes the leading edges, and then we have now the outboard flaps, the ailerons also, and of course the horns and the spoilers. All right. So these are the two trapezoidal outboard box. All right, through two trapezoidal outboard box. So you have the continuation of the leading edges, which are protected from the icer boots, and of course we have the ailerons left and right, and the spoilers also, a single spoilers left and right, and your outer flaps. All right, and of course to include your wingtips and the wingtips and the horn of your ailerons, which is electrically heated. Your leading edges is pneumatically heated. All right. So, and then wingtips. So aerodynamic continuity between the wings and the aileron horn, which are heated and located at the end of the outer box. The wingtips accommodates and at the front edge is the navigation lights and the strobe lights. All right. Navigation lights and your strobe lights. All right. So yeah, you have now your leading edges, which are the eyes. So 2 leading edges in the center wing, 1 and 2, and the 4 leading edges in the outer wing, 1, 2, 3, and 4. So this structure is comprised of a lightning protection and pneumatic de-icer boots. All right, and then in the outer box is also we have the outboard flaps. All right, we have the inner flaps and the outboard flaps. All right, and of course to include your spoilers. All right, and of course at the end of your outer box, you have now your ailerons. Left and right. which is in between your 21 and 24. In the upper fixed trailing edge panel, you have your spoiler. And of course, the wing to fuselage pairing, which is also made of composite materials to cover the attachment of your wings in frame 25 to 27. All right, and of course you have the flaps, which is located in the center wing box, your inner flaps, and your outer wing box, which you can find the outer flaps. All right, now that is the wings, gentlemen, wing construction, the wing construction. So most likely, if you can see it, most likely the construction of your wings is composite, excluding your center wing box, which is made up of metallic structure. All right, now we go to your stabilizer. Our stabilizer is a T-type bolted to the fuselage tail section. So you have in the tail portion, you have the attachment to your vertical stabilizers. And of course, in the upper part of your vertical stabilizer, you have your horizontal stabilizers. All right. So the horizontal stabilizer, this one, is a cantilever type, which is composed of a movable leading edge and the main box. So what is that removable? So you can, of course, removable. So this horizontal stabilizer is a top end and vertical stabilizer bar by means of a bolt. All right, so this removable leading edge is conventional type construction with closed space rib. All right, and your horizontal stabilizer leading edge is equipped with the icing boots, the icing boots. So if you can see, this one is the icer boots, and you can see different segments that conforms your A and B, the icer boots. So the main box is made up of two spar box type construction, made up of sandwich panel, and the skin are fixed to the spar plans by a rivet. So they are being riveted. All right, so these are the construction now. So you have in the horizontal stabilizer, you have two elevators left and right, which are fitted in the horizontal stabilizer in the rear spar by three hinges. All right, three hinges, 1, 2, and 3. All right, so the elevator structure is made of carbon reinforced plastic with the honeycomb core, and the trailing edge accommodates the trim tabs. You have the trim tabs. All right, these are the trim tabs now, connected to the elevator structure by means of piano hinge. This is your piano hinge. All right, so the elevator are equipped with heated horns. So you have your horn, and this horn is electrically heated. All right, so we have also in the vertical stabilizer now, composed of the dorsal fin, and the fin, and of course the rudder. All right, so this dorsal fin is made also of a composite structure. This fin is fitted with rear fuselage by means of bolts, including the main structure box and the movable leading edge. The fin main box is 3 spars construction with sandwich panel, and it is bolted in the rear fuselage. Something like, yes, you have the forward and the rear, what do you call this one? Spar, but in the center, gentlemen, there is this what you call false spar. That's why we call that as something like, yes, 3, but actually it's only 2. So you have this one, the main back composed of 3 spar backs, spar structure. So we have the forward, we have the rear, but at the center, you have again another spar. But that one is up to that only. That's why we call that as false spar. All right, the false spar. So the movable leading edges is a conventional type construction with closed space rib. All right, and of course that movable is the rudder, which is hinged to the rear spar of your construction. All right. All right. So this is now the rudder. All right, which is you have 3 hinges connected to the rear spar. Rear spar. So one is fin rear spar by means of 3 hinges. 1, 2, and 3. So the construction of the 2 spar and material are carbon fiber reinforced plastic, and the trailing edge accommodates in the lower section trim tabs. You have the trim tabs, yeah, connected to the rudder structure by means of a piano hinge. So these are the piano hinge, and the rudder trip is equipped with a horn, which is electrically heated also. All right. So how about in the wings? In the wings, can we see the wings? Let's go back to the wings. So this is now your wings, gentlemen. But of course, in the wings, the engine mount, gentlemen, of course, that is the location for our engine mount to support the engine. So if you are looking on the nacelle, contains the engine and related equipment. They comprise the main frame, which carries the cowling fairing assembly. The nacelle are fixed to the center wing box. You see that one now? The nacelle is within the center wing box. Lower, you see the center wing box, gentlemen, up to rib number 13. Rib number 13. But the support for the engine is most likely between the rib number 10 and 12. All right, so if we go back to the wing section. All right, so see this one. This is up to rib number. Okay, this one. Okay, no, that is the trapezoidal. This one. Okay, okay. So rib. Okay, rib 0 and rib 13. But the attachment of your wing support, engine support, I mean, it's from rib number 10 to rib number 12. Rib number 12. So that is the support of your wing. So this is on the right-hand side, and this is on the left-hand side. So this is your number 10 and number 12. So that is the engine support. All right, 10 and 12. All right, rib number 10 and 12. This is your 10 and this is your number 12. All right, that is the support for our engine. All right, so see this one between your section or rib number 10 and 12. All right, so there you can find out the attachment for the mounting. All right, mounts. All right, so yeah, the front section, you have the front section. So the nacelle front section includes the front engine mount. So this is the front engine mount now. Yeah. and of course attached to the rear engine mount also with 4 tension bolts. So we have also your rear mount. So tension bolt passing through the intermediate frame. And titanium front engine mount is lattice structure composed of welded die force nodes and tubes. These are tubes. All right, tubes. Okay, and of course we have the lower part of the nacelle section includes the air intake. All right, you see that one, gentlemen? This is now your air intake. All right, that is the air intake. That is the lower part of the nacelle. So includes your air intake. And the cowl is composed of forward structure with extend to the propeller pane to the intermediate frame, and which accommodates the air duct and airframe of the oil cooler and the up structure between the intermediate frame and the forward under wing box. All right. So, and of course, they are being interface to the upper nacelle through your different flange. All right, this one. So you have the B interface, gentlemen. All right, so you have the air intake cowl under wing junction rod. So those are the B. We have also C. All right, the intake cowl intermediate frame junction rod, and also the D. So we have the D also, and that is the intake cowl front mount attachment fittings. All right. Okay, and of course you have now your cowls left and right to access your engine, especially during oil servicing. If you open that, of course, you have your 2 hold open rod, which is a telescopic rod, and can be secured by 4 latches. You have your 4 latches here. So we have this one, 4 latches. And there are piano hinges on the top. And you can secure it by a telescopic rod. All right, and of course we have the firewall, gentlemen. So as we all know, part of your wing tanks is in the center wing box. Is it in the center wing box? So it means to say we need to secure that center wing box for possible fire in the engine by means of a metallic firewall. So that metallic firewall, intermediate frame of the forward frame of underwing box above the engine, and delimits the fire protected zones, allowing connections between the engine system and the aircraft system. So to protect the tank from fire, they have this firewall. All right. Okay, and then you have also 2 lateral cowls, permits the access of hot section of the engine. They are attached by a quick release fastener and intermediate frame. So a lot, you can just, what do you call this one, loosen quick release fastener in order for you to access the hot section of your engine. But that one, it's still made up of carbon Nomex sandwich. All right, what else? So you have now the connections. All right, so the attachment now through your forward, what do you call this one? Spar, forward spar. All right. So the nacelle center section includes the rear engine mount that attached by a 6-point to the center wing back. So that is the center wing back, because this one, gentlemen, this is 11, this is 12, this is 10, something like that. So meaning to say the end of your center wing box is read number 13. So most likely that's why it's this one, gentlemen. If this is the rib number 13, the end of the center wing box, this one is number 12, and this one is your number 10. And they are looks likely the same fittings. All right. All right, what else? All right, how about the rear section? The rear section now of your nacelle comprises of underwing box structure composed of light alloy shell structure. All right, so the forward frame comprises of firewall also. So the underwing box is attached to the lower surface of the wing box by two vertical fittings attached to the forward frame, bolted to the corresponding fitting of the rear spar lower cap by a half light alloy frame bolted to the rear spar lower cap, and two angles ensuring the continuous junction between the underwing box side of the wing box lower panel. So the metallic duct, including the thermal protection, ensures the hot gas evacuation and protected by the box structure. So as you can see, this one, this is now the exhaust part of the engine. That's why you have the hot gas evacuation, which is protected by the box structure. All right, so that is the interface of your engine system, which is located in the center wing box between your frame number 10 to 12. All right, now we go to your windows. All right, windows, many kind, mainly three kinds of windows installed in the ATR. We have the windshield, cabin windows, cabin windows, and inspection and observer windows. So normally in the cockpit, you have your windshield, the forward side window, and the upside window, which are fixed. This window consists of 6 panels, captain 3 panels, FO 3 panels. All right, the flight deck windshield can be flat and made of laminated glass, or curved. It can be flat, it can be curved, and made of stretched acrylic. So the forward ones are equipped with defogging and de-icing. So this one, the windshield is equipped with defogging and de-icing. So electrical heating. All right, you have the electrical heating. So yeah, we have also your cabin compartment windows. So the cabin windows are fail-safe type comprising of double panels with layers of air separation and made of acrylic materials. So in the area of the propeller, plans are fitted in different way, respected to the typical installation. So something like, it's just like the 2 panels, gentlemen. We have the inner pane and the outer pane, and you have the layer of air separation between the two plane, or the 2 pane, the inner and the outer pane. All right, so we have also this one, the inspection window may be carried out from the inside of the aircraft. No removals are required. So the damage type is in-pane cracking delamination. All right, so if the depth of the plane cracking or delamination initiated with the radius of a rabbet is a unit of 1.27 millimeters, and the length is not laminated, can be extended along the periphery of the outer pane. So between 1.27 millimeters and 2.5 millimeters max, length limited to 25.4 millimeters, maximum 2 defects are permissible. All right. So you need to inspect those windows if there are cracks. All right, 2 defects. Example for this one, we have this one, the first one and the second one, but maximum of 2 defects are still permissible. But if something like propagating, then most likely you need to repair. So inspect, yeah, visible part of the edge of the from the base of the rabbet to the outboard surface of the outer pane and the circumferential blend radius. So you need to check. You need to check. Flashlight beam may be required to check the edge of your windows. All right. So this part describes the most important visual check that must be accomplished on the structural part in the event of anomalous aircraft flight conditions. So in access platform, is necessary for visual inspection on the upper section of the fuselage, wings, and stabilizer. If damage or anomalies are found during the visual inspection, refer to relevant chapter of your SRM. So you do the inspection. Example, unusual. Maybe you have an unusual event. All right, unusual event. So what to do? You do a visual inspection. Example, bird strike, something like that. Or a lightning strike. Or something like even the hard landing. So you need to do some visual check to look for an anomalous event for a particular flight conditions. So, and you need to refer it to your SRM. So at least you need to identify. After identifying, you need to assess. And as per SRM, maybe you can repair, yeah, permanent, something like that, permanent repair, or if not, then maybe call ATR if beyond the repair limits. All right, so in case of flight turbulence or hard landing, is reported visual check, refer to JIC 055110 for hard landing. All right, so we have the hard landing and flight in turbulence. So what to do? So in the center and the upper wing skin panel, do not show wrinkling. So do not show wrinkling. Wrinkling, I mean the skin panel, gentlemen. If you see the skin is smooth, right? But if you something like wrinkling, something like that, waving, then most likely stress. All right, and then there are no screw or rivet loss. So screw 1, rivet 2. So if more than 1 for the screw or more than 2 for the rivets, then most likely it needs repair. So wing to fuselage fairing, do not damage. There are no fuel leaks, in the wing lower surface. Fuselage skin are not cracked or deformed, especially on the upper part of the fuselage. There are no loose rivets at the longitudinal panels. Your forward and rear pressure bulkhead not damaged. Floor panel not damaged. Stabilizer do not show damages. Stabilizer skin not showing wrinkling. There are no screws and rivet loss. There are the fairings not damaged. Cowling and fairing essential not damaged, and nacelle under wing box do not show damages. So you need to do inspection if you have some reported anomalies or events like hard landing or in-flight turbulence. All right, so how about this one? In case of hailstorm, so you need to check again. So, and the reference is JIC 055112. So look at the status of your radome, the fuselage upper section, dorsal fin, windows, windshield, and framings, your fairings, the iso bolts, leading edges, the movable surfaces, navigation lights, and nacelle and cowling. So most likely no damages. But if you find damages, so you need to do some repair as per SRM. All right. About this one, in the event of lightning strike. All right. So in the event of lightning strike, two kinds of damages are possible. We have a direct damage due to lightning or damage resulting to static electrical discharge from the aircraft. So what to do? What to do? So damage due to direct action of the lightning are usually located in the leading edges. So check the leading edges of your horizontal and vertical stabilizer, including the radome. So instead, the part most affected are from the static electrical discharge. So take also take your time also to look at the proximities of the what do you call this one, of your flight controls, including the tail portion, looking for damaged static discharger. All right, and also not only the static discharge, but also your antenna, propellers, including your aileron horns, leading edges. All right, so in both cases, a detailed visual structure check must be performed with a particular attention on the wings, to fuselage fairing, your skin, upper fuselage, dorsal fin, even windshield. All right, your fuselage skin, rivets, emergency exit, lower and the upper wing surface skin, your leading and trailing edges, and even your engine nacelles. Looking after this one, lightning strike. All right, lightning strike. So have you seen a lightning strike, gentlemen? So the picture of this lightning strike is para siyang ano, yung parang welding spot, ganun siya. And there are some instances that if there are lightning strike, it's not only those lightning, what do you call this one, yung parang welding spot that you can see along the structure, but it can even damage your static dischargers, your antenna, propellers, and aileron horn. I've seen a lot of damages in the static discharger and even in the antenna. All right, for this one, as per my experience. All right, so yeah, a lightning strike, yun, see, para siyang ganyan, para siyang ispat. All right. So for the structure, you check corrosion. So the easy accessibility of the modern procedure, which are currently used by the ATR, permits the operator to operators very effective means to detect and to clearly identify the extent as well as the depth of the corrosion. So this is achieved by normally, number one is visual inspection. If you see something, obviously, what we do now is reverting now to detailed visual inspection. And if you go in the detailed visual inspection, it can elevate to adequate inspection techniques like using different types of tools also. All right. So common methods of inspection is the eddy current. So you have now the NDT, X-ray inspection, and ultrasonic. All right. So note, it should be noticed that ATR aircraft secondary structure is a composite material. So see this one now, 14% and 18% of the aircraft operating empty weights respectively, which are not subject to corrosion. That is your composite materials. All right, so a lot of composite materials specifically for the wings and flight controls. All right, so these are the need to check for corrosions. All right, so zonal, under, galley, and lavatory beams, your internal boxes and rear spar faces, and your areas inside the landing gears. All right, and to include also your cargo compartments. All right. Now, how about bird strike, gentlemen? Bird strike. So you need to check, also inspect in the event of bird strike. You do your visual check to perform in order to ensure that structure does not show evidence of displacement, distortion, fastener holes, elongation, and tear out, flanking panes, skin cracks, fold or missing fastener, propeller, and engine inlet. So as per procedure for checking the bird strike visual check, in reference to JIC, that is your 053117. So if there is possibilities of bird strike, you need to check the nacelle structures, the stabilizers and leading edges, wing leading edges and trailing edge, your honeycomb panels for cracks, delamination, or core damage, flight compartment windows, fairing, and the propeller and engine inlets. All right. All right. Okay, to include in your structure is jacking. All right, this is your 05 ATA 05 jacking. So we have 5 jacking points, gentlemen. 5 jacking points, 2 in the forward, 2 in the wings, and 1 safety jack. All right, so 2 jacking points located in the lower surface on the wings, directly below the wing spar. We have 2 jacking points located in the lower part of the fuselage nose section, and 1 in the lower part fuselage in the rear center sections. So these are the jacking points location. All right, and you have the jacking point, and of course you need to remove that and replace it with jacking pads, jack pads. And in the forward section, you have 2 holes inside with cover, so you remove that also and fit the jacking pads and of course to stabilize the jack. All right, and on the tail portion, rear tail portion, you have also the up jacking points to stabilize your aircraft from tilting. All right, now in the aircraft, gentlemen, in the aircraft, sometimes you can see this one, the triangle. What does this triangle means? So that one, gentlemen, is you can identify if there is something like shearing. Yung fuselage niyo is nag-shear due to hard landing sometimes. Parang ganyan siya. So that is a alignment, gentlemen, na kung align yan, ibig sabihin tama yung yung structure ninyo, hindi siya nag-shear. So yan yung titignan diyan. So to permit the fuselage alignment, several datum lines are placed. They are the triangle reference point with the red central point. So kailangan kung kung hindi nag-shear yung fuselage ninyo due to hard landing, pantay-pantay yan. Diba? Pantay-pantay siya. So parang may sight diyan na makikita niyo pantay yung ating red central point. So yung mga red central point niyo na yan, yung checking the fuselage alignment is most likely located in 12 section 12 left and right, 13, 14, and 15. All right, parking and mooring or hosting and mooring. So during repair or inspection of the aircraft must be moored to avoid movement due to aircraft weight. So in particular, with the center of gravity and the wind speed condition causes aircraft to potentially unstable. So example, katulad sa atin sa Manila, kapag tinamaan ng ng tawag nito, ng bagyo, Anong mangyayari dyan? Siyempre, hindi stable. But the problem in Manila, I don't know in Clark also if you have that option, wala tayong mooring provision. Wala tayong mooring provisions na kung saan natin ikakalawit. Unlike yung mga gen of aircrafts, meron lang semento dyan, pwede na, di ba? Kayang-kaya nang i-hold yung aircraft. But for our aircraft like this, wala tayong mga mooring provisions sa rampa. So anong ginagawa ng Cebu Pacific pag may direct na bagyo na tatama sa Manila, inililipad na lang namin yung aircraft papunta sa mga stations na hindi affected ng bagyo. Ganun na lang ang ginagawa. Mas maganda nang magsakripisyo ka na lang ng konti, mababamoy mo naman yan, kaysa naman masira yung aircraft mo. Alright. So you have the reference, so GIX 073000. All right. So you have those jacking provisions or mooring provisions. All right, mooring provisions. So pwede nyong itali yung structure ninyo kung meron kayong mooring provisions sa ground. Unfortunately, wala nga eh. So anong gagawin? Paliparin na lang natin yung aircraft natin away from the storm. But lucky for you in leading edge, pwede nyong ipasok siguro yung aircraft sa hangar. Unfortunately, iisa lang siguro yung pwede doon sa hangar. Paano kung ilan ba yung aircraft na bibilihin ninyo? So if that's the case, so most likely, ilayo nyo na lang yung ATR sa kung saan walang direktang tatamang bagyo. Alright, mas maganda. Alright. We have also this one, hoisting. Hoisting, meron kayong mga hoisting provision. So kung bubuhatin nyo yung aircraft. Alright, so it can be located in two different places. We have left and right, and these are the stations where you can put your hoisting provision. All right, so about this one, composite repair mga kapatid. So most likely you have equipments, yeah, yung hot bander, meron tayong hot bander. So composite material applications for ATR represent significant technology improvements. Right, such as an improvement has led the major advantage over the competition in terms of weight saving. So improving fatigue and damage tolerance, reduce corrosion behaviors, and have largely contributed to ATR success in service operation. That's why specifically for the wings and the flight control surfaces, they are made up of composite materials. So repair to composite materials are mainly in two types. You have the cosmetic repair following a minor damage, or we have the structural repair damage that may compromise the structural integrity. So the accurate inspection must be made in order to locate and define the damage and extent of separation due to such damage. So you must have a something like a equipment. All right. All right. So first you do is inspect and look for the damage and determine whether light cosmetic or structural light cosmetic will only affect the surface layer. So surface layer lang siguro. So while structural damage will affect the subsystem. All right. Of the honeycomb adjacent structure, this can be done visually or the help of ultrasound equipment. So paano natin i-repair ngayon? This can be affected using a resin filler or dry layout with resins which then cured. So kailangan i-cured natin after repair. So curing provisions, of course, it refers to of your repair manual. So the structure is then finished and paint as required. All right. So example, may mga light damages kayo. So i-evaluate mo na rin natin, di ba? So light damage or heavy damage. So this type of damage affect the structural integrity. of the components or adjacent structure. So with this repair, the damaged material is usually completely removed and replaced. So kapag mga heavy damages, mas magandang tanggalin at maglagay na lang ng bago. So especially made plate of metals or composite material that is riveted in place, or the lamination can be repaired by installing rivet to hold the separated layer together. So you can find rivets here. So as you can see here, you have the repeated plate, and then of course it will be secured by rivets. All right, so this is the ultrasonic. So medyo expensive itong mga equipments na to for NDT. Yeah, ultrasound equipment. Okay lang doon sa yung mga metallic structure ninyo. Eddy current sometimes pwede na, di ba? But for the composite, it's the ultrasonic equipment. Oh, tapos na pala. All right. So that is our structure, gentlemen. So maliit lang na section to, and madali lang naman intindihin to. All my challenge to you guys is example, if there is something like damages specifically on the structure, you need to be familiarized also with the dent and buckle chart to enter it, and so that you can easily identify. So you need to assess first if within the limits or outside the limits. So if within the limits, you need to know what is the repair scheme, whether temporary or permanent repairs. And there are some instances that, especially for those what do you call this one, affected through pressurization, nagpo-propagate. Kaya nga mayroong repair interval inspection din. May mga inspection kayo. So if you do inspection at lumaki yung damage, then you need to assess again and look for reference. If the damage is beyond the limits, then most likely you need to contact ATR for instructions. All right. So yeah, mga kapatid, ito yung topic natin for today's evening. Yes, sir.
Yung nasa NABEX ba yung dent and buckle?
Ano, sir?
Nasa NABEX ba yung dent and buckle? Makikita.
Ganito, mayroon kaming mga forms. Ewan ko lang kung ano ang system, quality systems ninyo sa tawag nito sa leading edge. But example for us in A+, meron kami talagang parang forms lang siya. Forms lang naman 'yon. Forms, and then picture ng aircraft para madali yung ma-identify kung saan yung locations ng mga damages. So ibig sabihin, kapag na-locate nyo, you need to assess. After location, you enter in the dent and buckle chart. Because bakit kailangan natin i-enter doon sa dent and buckle chart? Baka kasi paulit-ulit, maaaring lumipad yung aircraft, umikot yung mekaniko, nakita niya rin, uy, meron ding dito, i-report niya. Pero anong gagawin niya? Pupunta ka sa cockpit, kunin mo yung dent and buckle chart, tignan mo muna, baka ma-double entry ka. Diba? Baka ma-double or triple entry. So normally,
Okay, sir.
once lang yan. Once. Isang form lang yan, kapatid. Isang form. Maybe one time kapag pupunta kami dyan, may mga forms kami na pwede nyong i-adapt para sa preparations ng aircraft ninyo. Diba? Ano lang yan, plus picture ng aircraft para madaling yung ma-identify. Kasi very critical to itong damages na to. Wala pa naman nangyayari, no, pero in some other aircraft, example, if you yung nanonood kayo ng yung aircraft investigation, Aloha Airline, what happened to the Aloha Airline? Nagkaroon ng mga crack, maybe because of aging aircraft. Kaya nga normally, kailangan nyo rin makita to, SMN aircraft ninyo kung gaano nakatanda. Kasi part to ng yung aging aircraft, most likely mas tumitindi yung structural inspection. And of course, not only the structural inspection, but yung tawag nito, yung CPCP. Ganon. Kasi example, dito kasi sa Pilipinas, as per our experience, lumilipad kasi yung aircraft natin within sa mga salty waters, and sometimes nag-cater tayo, especially cargos, yung mga salt water, ganon, mga isda-isda, ganon, nasisira yung mga styro at nababasa yung floor. Nako, pag nag-visual kayo, ang daming mga corrosions. So, kailangan very familiar tayo dito sa na to, pag-assess. And of course, you need to invest also on equipment like your NDT equipments. Para pag-check nyo ng yung mga depth, yung mga cracks, ganun, kung okay pa siya or hindi na. All right, so I think is there any more, guys? Any more? SRC. Yun. Meron din tayong SRC. Yun. Thank you. Structural repair card. Pero meron din kayong dent and buckle chart. Ganon. SRC. Kasi may mga instances, example, kahit yung mga lightning strike, yung mga binabanggit natin kanina, yung mga bird strike, you need to assess that, especially if the damage is doon in particular to the pressurized area. So kailangan ninyong i-dokumento yan, di ba? At from time to time, you need to check kasi yung po-propagate yung damage. All right, yeah. It's not only the dent and buckle chart, but also your structural repair card para ma-monitor nyo yung aircraft ninyo, specifically on structure. All right. Okay, mga sirs, so I think I'm done with my presentation, and so most likely tomorrow, mga sirs, it will be continued again by Mr. Brian Nolasco. All right. So is there any question, guys, relating to our topics for today for continuation and navigation, and of course the structures of your aircraft? So if none, guys, so maraming salamat sa inyo, and see you again maybe next week, next week, something like that, right, to continue with the other avionics and airframe subjects. All right, so maraming salamat at magandang gabi. Bye-bye.
Thank you, sir. Bye.
Thank you, sir.
Thank you,
All right,
sir.
thank you, sir. Thank you.
Thank you, sir.
Thank you, sir,
Thank you,
Proy.
sir.
Thank you, sir, Proy.
Thank you, sir.